All right, so today's warm-up says that there is an iPad connected to a keyboard, and those are representing intersecting planes. Okay, so sorry, the iPad and the keyboard are intersecting planes. Answer each of the following, true or false. All right, so all of these questions are dealing with whether the points are collinear and whether the points are coplanar. So remember from your homework or from your notes and vocab, collinear means I could connect them with a line. A line is a connected straight path. So collinear means I could draw a line through them. Coplanar would mean the same thing. It means they're in the same plane, or I could draw a plane through them. So notice, just remember that the lines are not always drawn in the figure. You need to be thinking about, could I connect those with a straight line? All right? So, number one, what'd you get? False. A, F, and E are collinear. I could not connect all three of those with a straight line. So they are not collinear. All right, number two. Very good. Number two is true. B, C, and D are non-collinear. They also cannot be connected with a straight path. Good. Number three. Do some erasing here. A, D, and C are coplanar. All 3 points, A, D, and C, all three of them are touching the iPad screen. So they are all in the plane of the iPad. Now, some of them are also in the plane of the keyboard, but we're not worried about that. So yes, these are all in the same plane. They're in the plane of the iPad there. And we're going to learn more about that later. Number four. Number four is going to get you. B, D, and G. Are they coplanar? So we just want to be careful here because collinear means I could draw a line through them. Coplanar means I could put a flat surface through all three of those points. And we're going to learn today in our lesson about how 3 points are coplanar. But notice, just because the plane isn't drawn doesn't mean the plane doesn't exist. So I just drew a plane and I included B, D, and G. So believe it or not, that one is true. And if you got it wrong, it's okay because we haven't learned that yet. It's like a pre-assessment. Okay, number five. F, E, D, and A are coplanar. So could I put a plane through F, E, D, and A? Could I put a plane through all four of those without bending my plane? I couldn't, because to go through D, E, F, I'm flat. I'm the keyboard now. To go through those three, I am the keyboard. Is A in the keyboard with them? No, A is not in the keyboard with them. So this one is true because those 4 points are non-coplanar. Is that confusing enough yet? So the answers were false, true, 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 true. Every day I'm going to show you the answers to the homework. You are going to check your answers to the answers that I show, and then you're going to let me know which ones you want me to work. You're checking your answer, and notice that the ones that have the ... means there's more answers. So yours might not be up there, but it doesn't mean yours is wrong. For number 1B, we were just listing all the possibilities. No, I don't think you had to list all of them. Remember, the order doesn't matter, so GA is the same as AG. Okay, so we're going over the homework. point line plane practice, and we are starting with 3C. 3C says graph the points and state whether they are collinear. So -3, -3, -1, -2, and 1, -1. Remember, collinear means I can connect them with a straight path. And so, yes, they are collinear. And so the answer to that one is collinear. Because, yes, I can connect them with a straight path. All right. 4A. Describe the statement as true or false. Does not want to let me scroll. Okay. CB is parallel to HI. CB is parallel to HI. So parallel lines are coplanar lines that do not intersect. Those are not coplanar. Those are not in the same plane. I could not put a plane through those. So you're right, those are not parallel, they're skew. So that's why that one is false. 4C. CF is parallel to AJ. CF and AJ. If you notice, those lines are going in the same direction, but they're in different parts of the figure, so they're never going to intersect. They're going in the same direction, but they're never going to intersect. So those are parallel lines. That one is true. Parallel lines have to be coplanar, so you're like, well, what plane are they in? Well, I could draw a plane and connect them like this, a flat surface. You could draw a flat surface shooting through your figure, and it would totally work. Why do we connect those dots? Oh, you don't connect... You connect C to F because it's a line, and you connect A to J because it's a line. But the only reason I connected them with my green pin was to show you that they're coplanar. You don't have to connect them like that. I just wanted to show you that they're coplanar. All right? E. AE and GF are skew lines. So, could I put a flat surface through those? Are those coplanar? And even though the plane is not drawn, doesn't mean the plane doesn't exist. There is a flat surface. There is a plane that I could connect these two. It's just that the plane is going diagonally through the figure. So you really have to be able to visualize these things sometimes. Okay? So that one is skew. False. All right, number 5D. B, C, D, and E are coplanar. This was probably the hardest question on your homework. You found it. That was the hardest question on your homework. And we are going to talk more about that in today's lesson. But let me tell you why this one is true. And another one just like this could be false. Why did this one make the cut and not the other one? So let me tell you why. The reason is because B, C, and D are in a row. They're collinear. They're lined up. So they are in this plane, but that's not the only plane that they're in together. I could pivot that plane, and I could draw a separate plane, and I could go grab E if I wanted to. So I could do this, I could go up here, I could grab E, and look at that green plane. Because they're in a row, I can pivot the plane, and I can rise up, and I can go grab point E. And like I said, we're going to talk about that more in our lesson today. 5E. A, B, and F are coplanar. That one's also true, and we're going to talk about today why that one's true. All right, so before we dive into the postulates that we're going to learn today, we're going to learn 4 postulates. Oh, someone just asked what papers you need. Right now, you need an empty sheet of notebook paper. We are taking notes. We didn't take notes yesterday. We kind of just discovered things, but now we have to write them down. You don't have to take notes over this slide because you already have the notation on your vocab sheet. So you don't need to take notes over this slide. We're just going to practice real quick. All right, how do you name a point? Let's say I wanted you to name this point. How do you name it? Good, you said it out loud. Good job. With one capital letter. That is how we name a point. All right, how do you name a line? I want you to name this line. How do you name a line? Correctly? It's hard, you can't do it in the chat because you don't have math type. So, capital P, capital J, line with arrows on top. You have to have two capital letters, and you've got to have that line with arrows on top, or it's not a line. Very important. Okay, how do you name this purple plane? How do you name? Good job, that was quick. So your notes say that you can name a plane with 3 or more points in the plane. Okay. Plane, so you can name it like we said. I'm going to just use 3 letters, but you can use 3 or more letters, which represent points from the plane. So I named it WZK. Did I put a line over it? No. Planes do not have lines over it. Did I put a comma between each letter? No. You just put 3 capital letters squished together. Yes, you can use 4 letters. Because you can use 3 or more letters, I chose to use 3. Nope, any 3 letters from the plane. Nathan, we're going to have to go over that later. Segment. Okay. I want you to name this segment. So we would name it like this. The only difference between a segment and a line is whether you have arrows or don't have arrows. Remember, the order does not matter. Okay? Name, I need a new color. Okay. Name this ray. Name that green ray. So be careful that with a ray you must start with the end point. Y had to be listed first. The order does matter on a ray. Y had to be listed first. All right, what's the symbol for congruent look like? It's like an equal sign with the squiggly on top. Yeah, good job, good job. You could probably find it in like the character codes. What does parallel look like? Show me on your camera. Show me with your arms. What does parallel look like? Yes, good job. And then perpendicular is an upside down capital letter T. That's perpendicular. Upside down capital T. All right. Now we're going to be, I'm going to come back to that. Okay. Now we're going to be translators. And instead of saying, I want you to translate from English to Spanish, I want you to translate from math language to English. So all of these are written in math language, and we're going to say what they are in English. You're already saying it, I know. Okay, so number 1. In math language, the symbols are up there. In English, it is ooh, ah, line, MT. Isn't that cool? We're going to come back to number 2. Number 3, ray, XY. Number 4, segment, HV. Number 5, ooh, what is it if it's just a capital letter? Good. Point A. All right, I'm going to twist my, didn't want to do that. I'm going to twist my magnifying glass around. Okay, number 6. Remember, you can name a line with a lowercase italicized letter if it's already on the picture, okay? Ooh, what's number 7? That's a longer one. Line GH is parallel to line IJ. So you would want to be specific and precise when you say that. Next one. Segment OK is congruent to segment RA. And last one. Line ME is perpendicular to line YU. Now let's talk about number 2. What happens when you don't put anything above it? That doesn't have a ray, a line, or a segment above it, so let's talk about it. I know, me is perpendicular to you. Yeah. Okay. This I want you to write down in your notes. So I'm going to give you time to write this down in your notes. You only have to write the good in your notes. You don't have to write the bad. Just write this in your notes. I want to take a minute to really talk about the difference between this and this. So this first one, that is a segment. It's like an object. It's an actual geometric thing. It's a thing. Now, when you don't put the segment over it, this right here, this is a length or a distance. It's an actual number. So the first one is an object, and the second one is a number. So you have to be careful. With objects, you use a congruent symbol. But with numbers, you use an equal sign. So it's an object versus a number. An object versus a number. So why are the goods good and the bad's bad? So notice, you can't have an object equaling a number. That's bad. You don't say, oh, this triangle equals 7. Well, what about the triangle equals 7? Its perimeter, its area, what about it? So a segment, an object can't equal a number. An object also can't equal an object. You would never say this triangle equals this circle. No, you use equal signs for numerical values. And then this is congruent. You can't say that a number is congruent to a number. Numbers are equal, numbers are not congruent. So, did I make myself clear? Are we good on this one? Okay, let's move on. I hope you got to write some of that down. If not, you can always watch the recorded lesson and press pause. We already did that. Okay, this is what I want you to write in your notes today. We have 4 basic postulates. So you can do 4 boxes in your notes, or you can just number 1 through 4. These are very important. 4 postulates where everything in geometry builds off of. We learned 2 of them yesterday. Postulate number 1 was through any 2 points, there is exactly 1 line. Through any 2 points, there's exactly 1 line. So write that down. That's basic postulate number 1. Building blocks of geometry. Then we discovered that if 2 lines intersect, remember they don't have to intersect, but if they are going to intersect, then if 2 lines intersect, they intersect in exactly 1, and I ran out of room, sorry, point. So that's pretty much saying when 2 lines intersect, you get a point. When 2 lines intersect, you get a point. That's postulate 2. So kind of back to my cube here. When my blue line intersects this red line, you get a point, you get a corner of the cube. So when 2 lines intersect, you get a point. And a point has infinite lines. Yes, or no. And one point has infinite lines. Oh, that go through it. Yes, but that's not one of the postulates, but that's true. Okay, we're going to learn postulate 3 and 4. Ready? All right, so we know if two lines intersect, we get a point. But what do we get if two planes intersect? So if two lines intersect, we get a point. If two planes intersect, we get a, very good, we get a line. Guys, there's no other choice. Two planes can't intersect and you get a point. Two planes can't intersect and you get another plane. Doesn't work that way. If they intersect, because they don't have to intersect, if they intersect, you get a line and only a line. So that is postulate number 3. I'll let you write it down. You don't need to draw the pictures, just write the postulate. Yep. Next one. This is the last postulate. We want to find out how many points create a unique plane. Don't yell out the answer. Don't type the answer, because we want to discover it, because when you discover something, you remember it better. So, I wish I could have sent skewers and whiteboards to all of you, but instead we're just going to watch Miss Tanton demonstrate. So, if I have 1 point, we're going to take this, the tip of this skewer is our point, okay? If I have 1 point, would it be easy to balance this whiteboard on 1 point? I'm having trouble. You see? It's not easy to balance this plane on 1 single point. In fact, through that 1 point, I have an infinite number of planes. Just like through 1 point, there's an infinite number of lines. See, I can rotate. I'm still holding on to the point. I have the point, I have the point, I have the point. All right. What about 2 points? 2 points is going to be more stable, right? But can I balance this whiteboard on 2 points? And I need more hands. I need to be an octopus. No. I'm cheating. I'm using my finger, so that's why it's balancing, because I'm cheating. Once again, if I have 2 points, my plane can pivot. Do you see it pivoting? See how it still contains those 2 points, but it's pivoting? Okay, so now let's try 3 points. Dun da da da. 3 points. 3 skewers. Now can I balance my whiteboard on 3 points? Let's see if I can do it without cheating. Hallelujah. You see it? Kind of. It's dark. Okay. Now, can I pivot my whiteboard? Well, as soon as I pivot, I lost a point. And then I try to pivot this way, I lost a point. And then I try to pivot this way and I lost a point. I can't pivot my whiteboard without losing one of my points from my skewers. So, how many points does it take to create a unique plane? It takes 3 points. Now, what if I got smart and I put those 3 points and I lined them up in a row? Would I be able to balance my whiteboard if I lined those up in a row? No. So what's the stipulation? I need 3 points, but what needs to be true about those 3 points? They need to be non-collinear, spread out. Yes, they need to be spread out. So here's postulate number 4. Through any 3 non-collinear points, there's exactly 1 plane. Non-collinear is key. If you have to go, you have to go. Just make sure to do tonight's homework. 2 planes blank intersect in exactly 1 point. We're using our postulates to answer these. Never. Very good. There might be quiz questions like this tomorrow. 2 planes never intersect in exactly 1 point because they don't intersect in a point, they intersect in a line. 2 lines are blank parallel if they never intersect. Always, sometimes, or never. Sometimes. Because If they don't intersect, they have two choices. They could be parallel or they could be skew. So that's why it's sometimes. Sometimes they're parallel and sometimes they're skew. 2 points are blank collinear. Always, sometimes, or never. The answer is always, because there's no 2 points in the universe that you could draw that I couldn't connect with a straight path. I could connect any 2 points in the universe with a straight path. So any 2 points are collinear. All right. Always, sometimes, or never. A line and a point are always, sometimes, or never coplanar. This one's deep thinking problem. A line and a point. Okay, here's my point. Here's my line. How many points does it take to create a line? How many? It takes 2 points to create this line. So how many points do I have in all? How many points do I have? I have 3 points. And guess what? I can put a plane through any 3 points. I can put a plane through any 3 points. So a line and a point are always coplanar, because I could always draw a plane through that. And remember, the plane goes on forever. Now, if I had 4 points involved, then it's a different story. But I had 3 points involved. A ray, always, sometimes, or never, has more than one end point. I'll answer that question. A ray never has more than one end point. Wait, I got a few questions. One question was, can a plane be a triangle? So guys, you have to remember that a plane is a flat surface that goes on forever. So you can represent a plane with a triangle. You can represent a plane with a triangle, but that plane keeps going. So that plane's not really a triangle, but you can represent it with a triangle. Okay? Name the intersection of the planes. Name the intersection of GCB. So there's one plane. They only use 3 letters, but you only need 3 letters to name a plane. And plane ABC. So it's pretty much saying, where is the green touching the blue? What points do they have in common? So what is the intersection of those 2 planes? Well, our postulates say if 2 planes intersect, they intersect in exactly one line. So you should be naming a line, and the name of that line is CB. Hopefully you got that. You want to try the harder one? The next one's harder. Name the intersection of GHA and FED. I'm going to see if you can do it without help first. Name the intersection of GHA and FED. Didn't see that. Very good. One of these planes is shooting through your prism, so that got kind of confusing. And the other plane is this side right here. So it's saying, where does the purple intersect the red? And the answer, y'all were all saying it correctly. The answer was DA. Very good. Okay. This is the last thing, and then we're done, and make sure you do your homework tonight and look over your vocab. Could it be a segment rather than a line? Yeah, when 2 planes intersect, you get a line, but in the picture they look like segments. So if you put a segment, I'm not super worried about that. Is it possible for 2 planes to be skew? Can 3 lines intersect and be coplanar? They could. They could, but they don't have to. So here's 3 lines intersecting, but these are not coplanar. Look at them. They're jutting out everywhere. But here's 3 lines intersecting, and they're flat. It's a flat surface. So they could or they could not. Sorry, I know you're asking me that because it's on the homework. All right, the answer to this right here is no. 2 lines can be skew, but 2 planes cannot be skew. And the reason they can't be skew is because normally, okay, they can be parallel, right? They can be parallel. But when I try to make them skew, this one's going to run into this one. It's because they continue in all directions instead of just 2 directions. So they can't be skew, but they can be parallel. One thing I forgot to say on your homework is on number 3, C and D, for some reason the font didn't get italicized. But for those to really be planes, it has to be italicized. I know you probably don't care about that, but I really care about notation, so just make sure you know that those are supposed to be italicized.